Hello, how to solve this radical problem? This is square root of n to the power of 3 equals square root of 5 to the power of 3. Now, let's solve this. If you have square root of a, this is a power 1 over 2. Square root of n power 3 is the same thing as n power 3 raised to the power of 1 over 2. And for this, we have 5 power 3 raised to the power of 1 over 2. Now, if you have a to the power of n raised to the power of n, this equals a to the power of m raised to the power of m. So we have n to the power of 1 over 2 raised to the power of 3, and this equals 5 raised to the power of 1 over 2 raised to the power of 3. Remember also, x power 1 over 2 is the same thing as square root of x. So we have square root of n raised to the power of 3 equals square root of 5 raised to the power of 3. We move this over here. So we have square root of n raised to the power of 3 minus this is square root of 5 raised to the power of 3. And this equals 0. So let's solve this using this identity. If you have a power 3 minus b power 3, this equals a minus b times a squared plus ap plus b power 2. This is my a, this is my b. So I have square root of n minus square root of 5 times square root of n power 2 plus square root of n times square root of 5 plus square root of 5 power 2, and this equals 0. So from here, I have square root of n minus square root of 5. Then this cancel this, I have n plus this times this. I have square root of 5n plus this cancel this. I have 5, and this equals 0. So let's equate each of these to 0. I have square root of n minus square root of 5 equals 0. Also have n plus square root of 5n plus 5 equals 0. To solve this, I move this over here. I have square root of n equals square root of 5. This cancel this, I have n equals 5. That is my n1. To solve this, I move 5 and n across the equality sign. So I'm going to have square root of 5n equals negative 5 minus n. I take the squares of both part of this equation. This cancel this, I have 5n equal this is negative 5 minus n times negative 5 minus n. So from here, I have 5n equals negative 5 times negative 5. This is 25. Negative 5 times negative n plus 5n, this times this, plus 5n, this times this, plus n squared. So from here, our 5n equals 25 plus 10n plus n squared. I move 5n over here. I have 0 equals 25 plus 10n minus 5n plus n squared. So from here, I have 0 equals 25. Then n minus 5n, I have plus 5n plus n squared. Let's rearrange this. I have n squared plus 5n plus 25 equals 0. So we solve this using the formula method. We have n equals negative b plus or minus square root of b squared minus 4 times ac divided by 2a. The coefficient of n squared here is a, the coefficient of h is b, and this is c. So from here, I have n equals negative b raised to negative 5 plus or minus square root of b squared 5 power 2 minus 4 times 1 times this is 25 divided by 2 times 1. So from here, I have n equals negative 5 plus or minus square root of this is 25 minus this is 100 divided by 2. So from here we have n equals negative 5 plus or minus square root of this negative 75 divided by 2. So from here, we have n equals negative 5 plus or minus, there's minus here, I have square root of negative 1 times square root of 75 divided by 2. So from here, I will have my n equals negative 5 plus or minus this square root of negative 1 here is I. So have I times square root of 75. 75 is 25 times 3 divided by 2. So from here, I have n equals negative 5 plus or minus I times I have square root of 25 times square root of 3 divided by 2. So from here, I have n equals negative 5 plus or minus I times square root of 25. This is 5 times root 3. You have 3 here divided by 2. So what I can do is to factor out 5 over 2. I have n equals, so we have 5 divided by 2 times, this will be negative 1 plus or minus I root 3. Now we have two complex values for n. We have n2 because we have already gotten n1 is 5 over 2 times negative 1 plus I root 3. We also have n3 here equals 5 over 2 of negative 1 minus I root 3. So these are the two complex values for n. We also have one real value for n, which is n equals 5. Here is it. So you can easily test by inserting this particular value for n. It's very simple. You have square root of n power 3 equals square root of 5 to the power of 3, and n equals 5. So you have square root of 5 to the power of 3 equals square root of 5 to the power of 3. And from here, you have square root of 5 to the power of 3 is 5 times 5 times 5. That is 125. And this equals square root of 5 to the power of 3 is 5 times 5 times 5 again. That is 125. You can as well test for the complex solutions if you are able and drop it on the comment box. Thank you and goodbye.